Okay, so this time we will talk about implicit differentiation. So look at this example. So find dy over dx given that y cubed plus y squared minus 5y minus x squared equal to -4. Okay. So based on this function form, actually it is not a function because it is not solved for y. Okay. Therefore, we can say that this is not a function form. So in this case, we cannot utilize the regular function properties and then methodology. So this time we will do a little bit different way. Okay. So first of all, as you see, the question asks you find dy over dx. So we know that this is one of the methods to define the f prime x. And in this case, because we cannot justify f prime x or the d over dx affect this form, that's the reason we using this form instead. Okay, so remember this cannot apply for this case. Okay, then how to do it? So I will show step by step slowly, so follow this step. So first of all, you are doing everything as single category and then you apply derivative rule. But remember, if this is y, so if this is y like that, then you need to do dy over dx. But if this is x like this, then you must write dx over dx. So what's the reason? So reason is we are still derivative by dx, and then this is y term, so dy over dx, and this is x, so dx over dx. Okay, so let me start doing it now. So this becomes 3y squared. Don't forget dy over dx. So we derivative y based on dx, and then plus 2y dy over dx minus 5 dy over dx minus 2x dx over dx and equal to 0. I mean, in this case, the reason I didn't put the x over dx over dy over dx because of derivative constant becomes 0. Okay. Now you need to highlight all dy over dx form here. So those three are dy over dx, right? So you factor by dy over dx in this case. Then this becomes dy over dx, and then 3y squared plus 2y minus 5 minus 2x, because it's cancelled out, equal to 0. So now this equation means we want to isolate dy over dx alone. So you don't need this one and this term here. So I'm going to move 2x on the other side first. So I'm going to add 2x. Then this becomes dy over dx 3y squared plus 2y minus 5 equal to 2x. Then last step, we divide by 3y squared plus 2y minus 5. As you see, this one cancelled out. So dy over dx equal to 2x over 3y squared plus 2y minus 5. So that's the derivative form of this expression, I mean the relation. Okay, So like this, because it is not a function form, so this case we have both x and y together. Okay? So let's continue one more example. So determine the slope of the tangent line to the graph of x squared plus 4y squared equal to 4. So as you see, y has also a square value here. So now we can define that most likely it is not a function. Okay? So this case also we are using implicit differentiation method, which means we will describe it dy over dx instead. Okay? Not y prime, not fx prime anymore. Okay. So, like other questions, we apply exactly same derivative properties, but don't forget you put dy over dx for y term and dx over dx for x term here. Of course, later you will cancel this out, so you don't see anything after x term anyway. Okay, so let me begin. So this becomes 2x dx over dx plus 8y dy over dx equal to 0. Now you know why I put 0 at the end, right? Yes, the derivative constant is always 0, so I don't even have to write anything. And then from here, if you know this is already cancelled out, and then write the only 2x, then you don't even have to write dx over dx, okay? Just write 2x, that will be fine too. Okay, so this becomes 2x plus 8y dy over dx equal to 0. So our goal is to solve for dy over dx. Therefore, I don't need this term and then this number. Okay, so I'm gonna remove 2x first. So minus 2x. Then ay dy over dx equal to negative 2x. And then we divide by ay. Therefore, dy over dx equal to negative x over 4y. Okay, so now we need to find out the slope of the tangent line. So this case, this form is both x and y. Therefore, you need to apply x into here and then y into here basically. So let me plug this. So dy over dx at the point root 2 and negative 1 over root 2 will be negative root 2 over negative 4 times negative 1 over root 2. Okay. So this becomes negative root 2 over negative 4 over root 2. So negative become cancelled out. So it could become positive. So this becomes root 2 times root 2 over 4, which is 2 over 4. Therefore, the slope becomes 1 over 2. Okay? So that's how we apply to find the slope of the tangent line for non-functional form.